Dear students, in the previous class, we have introduced Cournot model of oligopoly. But the model, as stated earlier, was based on the unrealistic assumption that cost of production is zero. Now, we generalize the Cournot model using the reactions curve approach and also assuming that the cost of production is not zero. But we continue to assume that firms produce a homogeneous commodity like a spring of mineral water or gadgets or something like that. And also we assume that the duopolies face the same demand. We present the model in the context of duopoly for convenience. Now, in the model of oligopoly suggested by Cournot, each duopolist, each firm must decide how much to produce, and the decisions are taken simultaneously at the same time. Now, when making a production decision, each firm takes into account its competitors. So the problem of the oligopolist is how much to produce, and the decisions are taken simultaneously. Not only that, when deciding to produce a particular level of output, it must take into account its competitor. Now, when one firm takes a decision, it knows that its competitor is also deciding how much to produce. If the competitors are A and B, as an example, the decisions are taken simultaneously. The decision to produce a certain level of output by A and B. When A decides to produce a certain level of output, A knows that its competitor is also deciding to produce some level of output, and the market price depends on the output of both A and B. So we can say that it is a simultaneous move game. It is a simultaneous move quantity setting game. It is a simultaneous move quantity setting game, if we use the language of game theory. So, two firms producing homogeneous products facing the same demand curve but with a different costs. The problem of each firm is to produce a certain level of output or how much to produce, and the decision to produce are taken at the same time. When each firm decides a certain level of output, it must take into account its competitors. and market price depends on the quantities produced by both firms. Now, to understand Cournot model, we assume that the firms face inverse linear demand functions of the form P is equal to A minus B Q1 plus Q2. The firms face what is known as inverse linear demand functions of the form P is equal to A minus B into Q1 plus Q2. And remember this, the demand function is P is a function of Q. Its inverse is Q is a function of P. From the perspective of a consumer, price depends on quantity. The demand function is Q is a function of P and its inverse is P is a function of. For a consumer, quantity depends on price. From the perspective of a producer, P is a function of Q. That is, this is the inverse of this. And for any function, its inverse exists if the function is monotonic. In non-mathematical sense, monotonic means the function either increases continuously or decreases continuously. So, this is monotonic, this is also monotonic. So, demand functions are monotonic. So, the inverse of the demand function exists. So, inverse linear demand function. Now, as you can see, the price which prevail in equilibrium depends not only on a single quantity, it depends on Q1 and Q2, two quantities, that is quantities by A and B. And for firm A, the cost function is written as CQ1. And for firm B, the cost function is CQ2. Cost functions need not be identical. That is, the demand function depends on quantities by firm A and B, but cost functions depends on the quantities of A and B separately. That is, cost function of A depends on Q1, cost function of B depends on Q2, whereas price in the market depends on Q1 and Q2. We also assume that MC and AC of the duopolies have the usual shape. Usual shape means the AC and MC curves are U-shaped. The usual AC and MC curves. That means the cost curves are the traditional MC and AC curves. They are U-shaped. Now, given two firms with linear demand functions and cost functions as given, we want to use the Cournot model to answer three questions. Question number 1, what will be the equilibrium level of output? Equilibrium level of output of the duopolies A and B. Question number 2, what will be the price in equilibrium? What will be the price in equilibrium? Question number 3, what will be the level of profits pi 1 and pi 2 in equilibrium. What will be the equilibrium quantities produced by A and B? What will be the price in equilibrium? And what will be the profits enjoyed by the duopolies A and B? And by equilibrium we mean a pair of output levels for A and B that are such that after they are chosen, neither A nor B has an incentive to change it. So equilibrium level of output means a pair of output Q1 and Q2 for A and B such that once it is selected, neither firm A nor firm B has an incentive to alter its level of output. Such an equilibrium is known as Cournot equilibrium. Such an equilibrium is known as Cournot equilibrium. We will say later that it is Cournot-Nash equilibrium using the language of game theory that we will see later. So it is simply a Nash equilibrium applied to a model in which the duopolies or oligopolies compete with each other choosing output levels. So this is known as Cournot-Nash equilibrium, or this is simply a Nash equilibrium in which the duopoly firms or oligopoly firms compete with the choosing output levels. Now, in order to understand the Cournot equilibrium and how it is reached, we use what is known as a tool known as reaction functions. Reaction functions. To explain how the firms reach Cournot equilibrium. Equilibrium means a pair of outputs Q1 and Q2 such that neither A nor B has an incentive to change it. The corresponding price is equilibrium price, and once price and quantities are obtained, we can calculate the profits of A and B in equilibrium. So, Cournot equilibrium can be better explained using what is known as reaction functions. Now, let us see what is meant by reaction functions. In every duopoly market, there is strategic interaction. In every duopoly markets, there is strategic interaction. Strategic interaction means decision by any competitor, any firm, partly depends on the decision by its competitor. Strategic interaction. And the final payoff depends on the action taken by the first firm and also the action taken by the second firm. That is, whenever there is strategic interaction, each firm responds to actions of other firm in some manner. And these responses are summarized into what is known as best response functions. Best response functions or reaction functions. In oligopoly markets, there is strategic interaction between the firms. It means that whenever an action is taken by one firm, there will be corresponding reaction from the other firms. Each firm responds to the actions of other firms in some manner. And these responses, these actions are summarized into what is known as the reaction functions or the best response functions. Now, the best response or the reaction functions specifies a firm's optimal choice for some variable such as output given the choices of competitors. So, the reaction functions are, or the reaction functions specifies a firm's optimal choice, a firm's optimal choice, a firm's optimal choice for some variable such as output given the choices of competitors. So, if the competitor is B, the reaction function of A shows the best response of A, that is the profit maximizing level of output of A given that B will produce or B will choose a certain level of output. So, using the Cournot model, let us assume that firms want to make as much profit as they possibly can. We assume that the goal, the aim of the firm is profit maximization. So, best response specifies A's optimal choice given that B has chosen a certain level of output. Here we assume that firms compete with the output. So, best response of A specifies the optimal choice for firm A about some variable, say quantity, given the choices of competitors, given that B produce a certain level of output, what is the best response of A? And we assume that the goal of the firm is maximization of profits. However, each firm has a problem because its profit depends on two things. One, output level its competitor chooses, and also output level that particular firm chooses. So, profit of A depends on the quantity chosen by B, its competitor, and also the quantity chosen by A itself. And as the game is a simultaneous mover quantity setting game, when A decides its output, it will never know what will be the quantity chosen by B. In all the other market structures, profit depends on its quantity. There is no reaction from the rival firms. But under oligopoly, whenever an action is taken by one firm, there will be reaction from other firms. So, profit depends on the quantity chosen by its competitor, quantity chosen by the firm, and also the fact that A has no idea about how much B will produce. Now, let us summarize the profit functions of A and B like this. Pi 1 is equal to P into Q1 is equal to, what is P? A minus B Q1 plus Q2 into Q1 minus P into Q minus C. Now it is Q1 minus C minus C Q1. The cost structure is given. So pi 1 is given by this equation. Pi 2 is equal to P into Q2 minus C2 is equal to A minus B Q1 plus Q2 into Q2 minus C Q2. So the profit functions are given as pi1 and pi2. And the price is given as A minus B into Q1 plus Q2. And this price is same for both the firms. P is equal to A minus B into Q1 plus Q2. P into Q1 minus C1, P into Q2 minus C2. Now, and as we know, the prices depends on Q1 and Q2. Profit also depends on Q1 and Q2, given the cost structures. Cost structures are specific to the firms. So both the price and also profits depends on both Q1 and Q2. Both Q1 and Q2. So in order to see how the reaction functions are derived and how each firm chooses its profit maximizing levels of output, we have to think about the reaction function of A corresponding to various levels of output chosen by B. That we will discuss in the next class.